Hi, yeah, we started day 40. Yes.
没开始，吓死我！他是8点半开，然后8点40上课。
那
别来，别过来，别过来！
没来，我回去了。快来，那你先关一下，别开着。
嗯。
喂。
Okay. Hi everyone. Can you hear me? Is my voice clear?
Yeah, I can hear you.
Okay. Good. Yeah, I don't think I can ask you to introduce yourself. There are like a lot of students, so I'll continue with the lecture. So probably I'll. If you guys can come to the office hours or like some other, like maybe we can, if you can come to the lecture like few minutes before the lecture, we can probably talk. I don't think I can ask you to introduce yourselves now. Yes, we are 80 students. Okay, so let's start. Okay, so this is so welcome to 251. So this is 251, and my name is Surya. Okay, so this is my email, Surya Teja at math.rutgers. And so yeah, so our lectures are on Monday and Thursday. The screen share is fine, right? You could see. Can you see the screen share properly?
Yeah.
Okay. Yeah. Okay. So we meet at the same time, 8:40 to 10 on Zoom. And Mr. Wiesler is the TA, so we met him yesterday. So he'll do the recitations from Wednesdays from 8:40 to 1:20, depending on your section. So you have 3 sections, depending on which section you are. You start somewhere in between 8:40 to 1:20. And so I'll post a lot of stuff on Canvas. So please try to check the Canvas site regularly. So you'll find resources, all your assignments, your homework can also be accessed through Canvas if you find from my lab from Canvas. So all of the stuff would be on Canvas. So please make sure that you check the Canvas site regularly. So, and the office hours will be on Tuesday and Friday. I didn't decide the times. These are my office hours, and then there will be office hours of TA, Wiesler. So I'll announce them like on Canvas maybe sometime today or tomorrow. So I didn't fix the time, so it will be some time in the afternoon, Tuesday, Friday. Okay, so that's the basic information about the course. And yeah, so there are some prereqs for the class. So Calc 2, some version of Calc 2 should be taken. The textbook is Thomas Calculus. So this is the 14th edition that you're using. You can get this textbook along with the MyLab access. So they have bundles, so you can purchase them together. So our homework is through MyLab, the online homework. So it's really important that you get this and work on the homework problems. Like in any course in math, it's important for you to like practice solving some problems, especially this class. There are a lot of ideas. So unless you actually solve some problems, you'll not really get much out of the course. So please get an access to the MyLab. If you get the MyLab access, you'll have an e-text inside the MyLab. If you don't want a hard copy, you can just get an e-copy from the MyLab access. Inside the MyLab, you'll find an e-copy of the textbook. And so, yeah, so you can buy this access directly from Pearson. And you can access, once you actually have an account on Pearson, you can log in through the Pearson account from Canvas, MyLab, and Mastering. So there's a tab called MyLab and Mastering on Canvas. So please access, so if you want to access your homework, you should do from this tab on Canvas. Okay. And so there's some technology requirement. I hope you're supposed to attend the lectures. It's synchronous, so all of you are required to attend the lectures while the lecture is going on. So I'll record the lectures. You can see them later, but you're also supposed to be online, and even all the exams will be online. So it's important that you have access to some internet, webcam, microphone, and like the computer, the laptop, or desktop computer. So these are department requirements for the course, tech requirements from the university in general. Okay, so one aspect of the class is that exams need to be authenticated. So we are using Proctor Track. So I hope you guys, there's a quiz 0 that was uploaded, and I asked you to kind of attempt quiz 0. It's just a question about what is your favorite topic. So the reason I want you to do this is because that if you don't do the quiz 0, you won't be registered on Proctor Tag. So I want you to, so like 50 of the students have done the registration, but I guess there are a lot more students who still have to do the registration. So please try to get into Proctor Tag and register. So if you have any problems, please send me an email, okay? So so the way to do is just on Canvas, go to Proctor Track. There's a tab called Proctor Track, and once you access that, you'll see the details, how to actually setting things up. So please make sure that you get your settings right. And so you probably, Proctor Track probably asks you to like set up your ID, your webcam, and so on. So you should be all set. So we might not be using Proctor Track for quizzes, but we'll be using it for exams. So please make sure that, and the exam is in like a couple of weeks, so the first exam. So please make sure that you have it ready. Okay. So again, so yeah, so there are resources about tech guide and resources. Please visit the Rutgers Tech Guide if you want to have access to, if you need any help about the tech. And yeah, if you have some financial problems, so you should email the Office of Financial Aid or the Dean of Students. Okay, so they'll probably help you out about like if you're purchasing any of these things. Okay. Okay. The next is the grading and the weightage for different aspects of the course. So we have reading assignments, we have the online homework, my lab, we have some quizzes, and a lot of midterm exams, and a final exam. Okay, so that's the 5% of reading assignments, 10% my lab homework, quizzes is 10%, midterm 50%, and final is 25%. Okay, so so there's a lot of, so we kind of decided on having a lot of midterms. So you'll get, so it's like we have 5 midterms. So it's typically smaller than the standard midterms that you see, but we have a lot of exams. So we should be ready to, okay, there's some issue here. Okay. Okay, so again, the first part of the course is about homework. As I said, online homework is graded through my lab. It's just an online interface, the application that helps you to solve problems. So please get an access to my lab as soon as possible and start working on your problems. So the first homework is due on September 17th. Okay. So, and other homework dates, you'll see them on my lab. So please check my lab for the other due dates. Okay, so in general, if you have any questions about my lab, you have technical difficulties, if something gets stuck or like something is not working on the my lab interface, so you should email the tech support of Pearson. So the first thing is to mail tech support, and our representative for Rutgers representative for the tech support, or like for the interaction between Rutgers and Pearson, is Ms. Melissa. So you should email her about the problems that you have. So first contact tech support, and then you should probably email Melissa with some numbers that you get from tech support if you need further help. So, okay, so please email these guys. If me or the coordinator, we can't really help you out with the technical issues. Like these are specific people that you probably should talk. Okay. If everything doesn't work out, please let me know. But like first things that you need to do is talk to these people. Okay. So if you have any questions about my lab, these are the people you should talk to. Okay. So, so the one part of homework, as I said, is the my lab assignments. But the second part of homework is official homework exercises. They're not for submission or for grading. You are supposed to solve them. So they are listed on the math website. So please have a look at them and try to solve them. They're similar to the MyLab problems, kind of, but it's important that you solve all these problems will help you for your exams, for instance. So it's important that you really solve them. Okay. So we are not asking you to submit them or we're not grading them, but it's important that you practice these official homework problems. Okay. So as I said, solving problems is really important. Okay. In general, it's in any part of mathematics, it's important that you understand how to solve problems. Like even when I learn a new topic, unless I solve a new problem, I don't really get that. So it's important that you practice as many problems as possible. Okay. So that's the homework part. And then we have reading assignments. So you're expected to read the textbook before each lecture. So there will be reading assignments posted. So based on so you're supposed to read the portions of the lecture that we're going to cover in the next lecture. So for instance, for the Monday's lecture, you're supposed to read some sections of the textbook, and at the beginning of the lecture, you'll have some reading assignment, a couple of questions, or like a small quiz kind of stuff based on your reading assignments. You're not expected to read it thoroughly. It's just we want you to read the textbook and get some understanding before you actually attend the lecture. Then if you actually have some reasonable idea, like a vague idea of what you are going to learn in the lecture, you'll probably get much better out of the lecture. So please read your textbook. So for instance, for the next lecture, please try to read 12.1, 12.2, and 12.3. Okay. So these are the sections of the textbook. Please read these sections, and yeah, so mostly the assignment will be for completion, in the sense that if you actually read that, you'll essentially get the points. Okay, so it's just 5% of the course. Okay. Okay, so if you have any questions, you can like type in the chat, or you can like come and ask me. You can unmute yourself and ask questions. Okay, so that's the reading part of the assignments. And then there are quizzes. There will be quizzes in the dissertations. So these are like typical quizzes that you might have seen in other classes. So they will be on the topics that we cover in the lecture. So some lowest, or like if you miss one quiz, they will be dropped. Okay, the score of one quiz will be dropped. Okay, so that's about quizzes. And yeah, so one new difference between other semesters and now is just that we have a lot of midterms. So we have 5 midterm exams on Monday, 9:40 to 11. So this is a slot that is booked for midterm exams. So make sure that you are free at the time. So if you have any time conflicts, you should talk to the math department. Okay. So anyone taking this class should have a free slot between 9:40 to 11 on Mondays. Okay. So the first exam will be on September 21st. It will be on these topics. The further exams, October 5th, 26th, 12th, and 7th. Okay. So the specific topics are listed like approximate topics for the exams, but the specifics might change as we move on in the class. Okay. And one more important information is that the exam will be on all Canvas site. Okay. It's a different, so you have 2 Canvas sites. One is a Canvas site for this specific section, right? And there's a Canvas site for all sections. So this is a coordinated course. So all of us, there are like five lecturers and 5 TAs. So that all of us together run this site. So you have, because the coordinated course, all the exams, all the sections will take the exams simultaneously. Okay, so the single exam that you'll have, so that's why you had to take the exam on this site. Okay, Canvas all sections. Okay, I'll remind you when we get to that part, but just have it in mind that exams are on all sections. Okay, so that's about midterms. And the final is the cumulative exam. I guess right now we're thinking is on December 15th. It's a 3-hour exam. So it's tentative. We're not sure about the date, but it will be somewhere around December 15th. Okay, it's a cumulative exam. Okay. So any questions about the course policies or the syllabus? Okay, so sorry, I didn't see the question in the chat. Homework has been posted. Yes, it's the first homework is due. It's on my lab. So you should see it on my lab if you have an access to the my lab. The second question is reading assignments. Oh no, the reading assignments are not on Pearson website. They will be, you'll see them as quizzes on the Canvas site. Okay, so Canvas site is a basic important site. Okay, so that's our course website. So we'll be using Canvas site. Okay, exams. I don't know which exams you're talking about. The Monday, the midterm exams are between 9:40 to 11 in the night. So this is a different slot, once in 2 weeks that you have. Okay, it's not on the regular lecture time. Somehow, yeah. So we're doing it differently this time. So this is a department decided to have the exams from 9:40 to 11, not at the lecture time. Okay, so during the lecture we'll probably review stuff, and then there will be an exam on a different slot. Will the slides be posted? Yes, you'll see all the slides posted. You'll see the videos posted on Canvas. I'll also post other resources for you to actually get stuff. So somehow, yeah, so don't expect the course to be very much like what you would have when we do our Blackboard lectures. So I'm going to slightly, yeah, so we're going to do things slightly differently. So please, yeah, I am recording. I think I'm recording the lecture. Yes, it's the class is being recorded. Yes. Okay. So yeah, so there are a lot of differences. It's important for you guys to work on stuff because of the online interface. It's yeah, I'm not sure how much interaction that we can manage between us. So it's I'll try to guide you through each and every problem and so on, but it's important that you guys also have work on your own for a lot of stuff. Okay, so okay, any other questions about when do you actually post the reading assignment questions? Oh, so this is, you'll see the assignments. I mean, it's you before. I haven't decided exactly, but it's supposed to be for the next lecture. For instance, for Monday's lecture, you'll probably see the assignment. So you're supposed to read during the weekend, and then you'll see some assignment on Monday morning or something like that. Okay, so you maybe it's like it's just one or two questions. You answer the question and then join the lecture. So something like that. So slightly before or during the beginning of the lecture that you'll see the assignments. Okay. So for the class, please review your Calc 1 and Calc 2. So this is important. So class is basically built on Calc 1 and Calc 2. So unless you have all these ideas pretty clear, it's really hard to do a multivariable calculus. So multivariable calculus is a kind of extension of calculus. So you should be comfortable with all the ideas in calculus. So main ideas that you, few of the main ideas that you studied, the limits, continuity, and derivatives. How to compute all these things? How to compute derivatives? What do they mean? How do you test many of these stuff? And what can you do with derivatives? You can use derivatives and second derivative to understand how the curves of how the function looks. You can draw the curves. You can understand the maximum values, minimum values, the extreme values. You can understand if things are concave, convex. So these are some aspects that you should review. So that's about derivatives, kind of this is part of Calc 1. And then we have some integrals, indefinite integrals, and the relation between integrals and derivatives. That's a fundamental theorem of calculus. So their integrals are kind of anti-derivatives. That's the statement. So somehow they're two distinct ideas, but they're related by the fact that integrals are anti-derivatives. Okay, and then you should try to, we won't use integration techniques that much in the class, but you should probably review. So there are ideas of integration techniques like integration by parts and substitutions at different kind of integrals that you'll solve. So, but this is important if you're doing maybe the next class, or if I don't know if you have done this 244, if you solve some differential equations, this kind of knowing how to solve integrals is important. We won't use that much of integration in this class, but yeah. And then using integrals to compute volumes, areas, understanding different kind of coordinates to changing coordinates. We are typically used to do x and y coordinates, but we can also do other coordinates, r, theta coordinates. So that's one aspect. And then there are series, Taylor series, summing series, and understanding. So if you have infinite expressions, how to manage these kind of expressions. So this is your calc. So please review these calc problems. I hope you have solved some problems yesterday in calc review in the recitation. Okay. So that is about the calc review. Okay, September 17 homework. Oh, so let me know if you can't see it. Maybe it's I'm not. I thought I published it. If it's not published, I'll publish it now. Okay. Okay. So let's see. So today is a very basic lecture. So we'll. Okay. So you people can't see the homework. So just I'll do it at the end of the lecture. So probably maybe it's not published. I thought I published it. I should probably change some settings. Okay, so I'll look into it. Thanks. Okay. So what is multivariable calculus? It's basically calculus. Okay. So what do we do when we study calculus? It's just that we study different functions, right? The relation between there's a variable x and there's a function f of x or y equals f of x, and we study these functions. Okay. So different aspects of these functions, how the functions look, what is the derivative, what are how do the tangents look, how do areas of these functions look, right? So we compute areas, we compute tangents, so different aspects of these functions. So we have one variable functions, this is x and this is y. We draw this xy function. For every x there is a y. So if you draw that, you get a curve, and we study different aspects of this function. So this is what calculus is about. Okay, so that's just something that you have studied, like if you have done a couple of calculus courses or more. So, okay, at the very basic, it's just studying these kind of functions, different aspects, so geometric aspects of the functions, or physical aspects of these functions, algebraic aspects, like how do you differentiate, different rules for differentiating, different rules for integrating. So different aspects of these functions are what you're studying. Okay, so that's what calculus is about. And multivariable calculus, as you would have guessed, is about more variables. It's just it's in the name. It's instead of studying a function that maps between one variable, for one variable it determines another variable, that's basic calculus. But if you have a function which depends on a lot of variables, so x1, x2, some x1 million, so the lot of variables, and for all those given those variables, you have some function that gives you a lot of other, instead of just one output, it gives you a lot of outputs, y1, y2, yn. So such a function. So we study functions which are of this form. So a lot of variables, and for each given these lot of variables, you have the outputs. So these are inputs here. So you input a lot of variables, then you would get a lot of output variables. So that's the difference. So this is the multivariable calculus. Studying functions like this is the part of multivariable calculus. So instead of just one variable x and y, we take a lot of variables x, a lot of variables y, and studying the relation between x and y, these different x's and different y's, is the idea of calculus, or the multivariable calculus. Okay, so so it's studying these kind of functions. And why do you want to study? What do you want to study in this? So you could guess. So if you have your notes for your calculus ready with you, or in general, if you see in the textbooks, whatever you have done for calculus, we try to do the same things for multivariable calculus. We try to develop ideas of derivatives, integrals, and more different other ideas. We try to extend the ideas to this context. Instead of just y equals f of x, if you have these functions y1, y2, yn equals f of x1, x2, xn, but in this context, we want to develop calculus. So that's the subject of a multivariable calculus. Okay, so yeah. So again, it's just trying to, if you really understand your calculus well, you should be able to guess what kind of things we'll do. It's the generalization from one variable to more variables. Okay, so that's first thing that you should know. It's from here to here, we are just generalizing to more variables. Okay, it might look complicated but it's at the very basic, it's a simple generalization from one to many variables. Okay, if you realize that, things will be more clear. So so because of more variables, things can get confusing, but the very basic, it's just this generalization from one to many variables. Okay, so why do you want to study multivariable calculus? Because not all functions that you see in real life or any system that you want to study are just functions from x to y. Okay, so a lot of functions that we study in real life, any system that you take in your life has a lot of variables. Like, it just doesn't depend on one parameter. It depends on a lot of things. For instance, if I have to determine my life, and like if you want to understand how my life goes in, what is the trajectory of my life, it's not enough to know, like, for instance, how much energy I have, or how much. It's important to know how, like, so a lot of variables. How much math am I learning? How much am I talking to people? How much am I helping the society? Different aspects, right? So it's not, so your life depends on so many parameters. And if you want to understand how your life propagates, you need to understand all these variables. So there are a lot of independent parameters. It's not, so in general, every system you study is very complicated. So it has a lot of variables. So that's the reason we study these systems with a lot of variables. Okay, so all these parameters can be things that are important. They're independent degrees of freedom. They're not related to each other. So x1 could be the time I spend on doing math. X2 can be time I spend with my family. X3 could be time I spend doing some social work. So it's so there are different parameters. So and all of them together will decide how my life goes through. And so you can think of y1, y2, yn could be like my happiness, how much happy I am, how much productive I am. The outputs would be happiness, productivity, and a lot of other things. How much work I get done, how much I teach. So all these depend on my parameters. Okay, so xi's are the independent degrees of freedom, and yi's, the outputs, are the features of the system. Okay, so you want to, although x1, x2, xn determine the degrees of the freedom, the features, like what features the system has, the things that you want to study are the yi's, the outputs. You could be interested in different outputs, not just one output. What does the system behave? So that's these yi's. Okay, so you could think of, so I would advise you to think of different systems around you. Everything you see around you will be dependent on a lot of variables, and it will have a lot of features. Okay, so that's why to study any system in the world, you need to kind of consider a lot of variables. Okay, the simpler systems will depend on one variable and will have one output. But if things are complicated, you'll have many variables as inputs and many variables as output. Okay, so you should try to think of any system that you see around and see what are the independent variables that it depends on, and what are the quantities that you're interested in, right? So for instance, in the world, the universe, there are so many things in the universe. There are different degrees of freedom. Every person is a different degree of freedom, but ultimately you want to understand like what happens to the world. For instance, you might be interested in different aspects of the world, like how much, whether it's getting better in terms of social aspects, whether it's getting better in terms of environmental aspects. So different, so depending on what you want to study, the thing that you want to study is the features, and what inputs that you give, the data that you give to study them is the variables xi. Okay. So again, so these functions x1, x2, xn till goes to y1, y2, yn. The reason we study them, so different, not only, for instance, some systems that you want to study, some specific kind of functions that you'll see in real life are what are called scalar fields, which are functions of space. The example, the functions of the space are, some examples are like at every point on the around you, you would want to know what's the temperature, right? Every point on the earth, different points on the globe, you want to know how is the temperature like. We don't have, not every point on the surface of the earth is at the same temperature. So you want to know how the temperature varies as you move around the space. So this is the function that depends on 3 coordinates, x, y, z, the space coordinates. And for all of those, given an input of x, y, z coordinates, the space coordinate, it gives you a temperature, just one parameter, y, okay, the t parameter. Okay, so that's some scalar fields. It depends on the space. So the space is not just one parameter, it depends on 3 parameters, x, y, z. So for every x, y, z, you have a value. Okay, so that's a function which depends on a lot of variables, but the output is just one variable. So that's a scalar field. And if you know some physics, like things like magnetic forces or in general forces at every point in the space. So for instance, gravity. So at each point in the space, the gravity looks different, and it also has a direction. Okay, so if you have a mass of a particle that you leave at some point in the space, depending on where you are, it might move in different directions. So at different points in space, you have different forces. It's not just the force now has a direction. So it's not just a single quantity. It will have a lot of, the output is also a lot of coordinates. So the input is space coordinates, and the output is also a vector, the direction. So that's also is determined by a lot of coordinates. Okay, so this is some place where you see calculus. You want to understand these kind of systems, for instance, or you want to know how. So when you study how a particle moves on the plane, you just need x, y coordinates, but if you want to study how a particle moves in the 3-dimensional space, like if you can move, you're not restricting it to the plane, it can move anywhere on the space, then you need 3 coordinates, x, y, z coordinates, to know where the particle is. So you want to understand particles moving not in just a plane. If you want to understand higher dimensional movements, you want to know some aspects of higher variables. And then, okay, and similarly, if you want to understand objects like surfaces and higher dimensional objects, you want to study multivariable calculus. For instance, when you study circles, parabolas, and other coordinate things, they all live on the plane. But if you want to study like a 3-dimensional object like Earth, right? Earth is like a spherical object. So if you want to study something like this, so you want, for instance, the question. So some question that you might want to think is, what is the volume of this object, or the area, surface area of this object? Okay, you might have learned the volume of a spherical object and the area, surface area, but you want to know why those answers are true, right? So you might have seen that some expressions for the area and volume. So we'll study why those expressions are true in this class, for instance. Okay, so for instance, for circle, the area is pi r squared. Here we have 4 by 3 pi r cube is the volume of a sphere. So you want to know why these answers are true. So if you want to study higher dimensional things, then also we need like instead of things lying on the plane, if you want to study things which are not lying on the plane, you want to understand surfaces. Okay, so that's the reason. So so I'm trying to convince you that there are a lot of everywhere around you, we see a lot of variables. Even in situations where you don't think there are a lot of variables, there are a lot of variables. Okay, so if you have, for instance, our computer, right now your system, the internet is working. So the way internet works is through a lot of data, and the data are, in some sense, are vectors of large variables. Okay, so they depend on a lot of variables. So most of the data on internet or everything that you see on a computer will be a vector of this form, will like 1 0 1 0 1 0 0 0 kind of a vector. So we need to manipulate this data, and create algorithms with it. So so you need to know something about more dealing with more variables and higher doing stuff with it. Okay, so so let me see those. Okay, so these are some examples, and so I don't know what majors you guys are in. Depending on what you study, if you study physics, you'll see a lot of this stuff. If you study any kind of engineering, you'll see these things. Not just engineering, every computational aspect that you see around. Most systems around. Like if you're seriously studying any system, you'll see more variables and the relations between different variables. So that's why we want to study calculus of these variables, right? So for instance, a lot of so these days there's a lot of improvements on artificial intelligence kind of neural networks or kind of programs. So all of them actually essentially do analysis of these kind of functions, high variable functions. So they some things called gradients and gradient descents. These are all things that you see in our class in the first few lectures. You'll see these ideas. Okay. So questions? Any questions before we start some topic today? So let's start 12.1, which is basic coordinate system, and we'll start with vectors in the next class. Okay, so wait. Okay, so let me move on then. Okay, so the first topic, 12.1, is about three-dimensional coordinate systems. So it's understanding how to give coordinates if you want to understand like to 3 dimensions. So if you want to like label a point in the space, how do we give labels to those points? Okay, so you got used to doing stuff on 2 dimensions, right? If you want to label points on the plane, you know how to give x and y coordinates, right? I hope you guys are used to that. So the main idea is to draw 2 axes. Oh, wait. Is there a problem with the screen share? Or? Okay, something is off. Okay, give me a second. I'm sorry. Okay, the screen share is gone now. Let me get it back. Okay, so yeah, so when we think it's back again, let's see. Can you see it now? The screen.
Yeah.
Okay, so let's see. So you want to study coordinates in this plane, for instance. We have this x-y axis, right? We draw an x-axis and y-axis, and then we label points based on, give every point on the plane. We give, if this is x, this is y, we call this xy, right? So that's how you give coordinates in the plane. This is something that you're familiar with. So this basic idea of giving, labeling points by numbers is a revolutionary idea this is called Cartesian System, named after this mathematician called Descartes. So it's one of the most revolutionary ideas in mathematics in general and like human life. It changed everything. It's I don't know if you appreciate it as much, but it's allowing you to do geometry, any kind of geometric ideas using just algebra and numbers, right? Just you can label points. Points are very geometric things, just something, points and lines and all these ideas. We can relabel them, or we can talk of these same geometric objects in terms of numbers. So you'll realize how good this idea is if you do more and more advanced mathematics, but it's one of the most revolutionary ideas in mathematics. Okay, so again, the idea is, as I said, you draw two axes and you label a point by the distance. If you move along x-axis, if it's 4 units along x-axis and 6 units along y-axis, so the point is 4, 6. Okay, that's how you label points on the plane. So this is one way to label. So this is the Cartesian system. So you guys have seen other systems like polar coordinates. You can label the point by the radius and the angle. For instance, you can label it with angle, this angle and the radius. So that's another way to label the same point. So the point is the same, but the numbers that we are giving to decide, so it's a way of calling, it's a way of naming these points, right? So we can give different names. So the giving xy coordinates is a specific way to name a point, or you can give r theta coordinates the different name. It's completely different. You can think of it as a different language. xy is the name in one language, and r theta is the name in a different language. Okay, so but it is a revolutionary idea. So we can talk about points using this just numbers, a couple of numbers. Okay, so that's about a if you want to decide how to label points in 2 dimensions. And the 3-dimensional system is completely similar. It's about labeling points in 3 dimensions in just a plane. If you around you, if you want to label points, you can't just do it by 2 coordinates, because there is things are not on a plane. You also have to move. There's a height aspect as well, right? It's not just a plane. You also have a height aspect. So that's why we take 3 axes. So we have on the plane, we draw x, y axis. This is x axis. This is y axis. And you draw a vertical z axis. Okay, this is z. Okay, so we have 3 axes like that. So can you guys imagine? So just you have 3 axes. If you have these 3 fingers, maybe you can see the 3 axes. So there is x-axis, y-axis, and z-axis. So they form, so left hand rule kind of. So if one point is x, this guy is x-axis, this guy is y-axis, then the top guy will be z-axis. Okay, so if you have x and y, you can find how z-axis exists. Okay, questions on this? The first setup to label points is to draw three axes, x, y, and z. All of them are perpendicular to each other. Just like you draw x and y on the plane, you draw another axis, z axis, perpendicular to the plane. You draw two axes on the plane and you just add an extra axis shooting from the plane. And it's above the plane. So you can draw, you can imagine drawing two axes, right? You can draw a line above the plane or below the plane. We kind of, our convention, this is a convention. So this is important to know. It's like once you draw this plane, the way we draw z-axis is above the plane, right? So if x is like this, y is like this, z-axis will be above the plane like this. Okay, so this is called the right hand rule. If you move from x to y using your right hand, something like this, z-axis will be on the above the xy axis. Okay, if you move from x to y on the plane, you'll see that what the thumb finger shows, the direction, that direction is the z-axis. Okay, again, we set three axes to label the three-dimensional space. Okay, so now let's see, how do we label points? Again, it's the same. So if you want to label points, you see how much distance you have to move along x-axis, how much distance you have to move along y-axis, and how much distance you have to move along z-axis. That gives you the coordinates x, y, and z. Okay. For instance, can you tell me what are the coordinates of this point P that you see here?
Would it be 3, 4, 5?
Yeah, so 3, 4, and 5. Yes. So there's three along x-axis, 4 along y-axis, and there's 5 along z-axis. So it's 3, 4, 5. Okay. So it's completely similar system to the two-dimensional coordinates with just we have an extra three-dimensional space. Okay. So if you want to imagine the three-dimensional, like in general on the plane, it's easy to see. In three dimensions, probably you need, unless you're used to thinking in 3 dimensions, it might be hard. So I'll advise you to kind of look around in your room. For instance, you'll see that there are, if you look around and you see in the corner of the room, you'll see 3 axes. You can think of them as x, y, z axis. Okay, look around and see. For instance, I don't know, in the video, there's a corner of my room. So you can see that there are 3 lines. You can think of those 3 lines as the 3 axes, x, y, z axis. Okay, so this is x, this is y, and this is z. And once you have that, when you start to think in terms of them, then you will be able to capture the geometric ideas. Okay. Okay. So let's see. So what is x-axis? So x-axis geometrically is something that you have drawn, right? So I have x, this, so and this is z-axis. So so this is x, this is y, and this is z. So what is x-axis? X-axis is the axis that you have drawn. So, but what will be the points? All the points on the x-axis will have coordinates of the form x 0, 0, right? It's on the x-axis. So there will be some x, the distance on the x-axis will be x. But because it's on the x-axis, the distance to the y distance is 0. Also the z distance is 0. You're not moving along the z-axis at all. So that's why the z distance is 0. Similarly, you're not moving along y-axis, so the y distance is 0. So every point on the x-axis will have coordinates like x, 0, 0. Okay. Similarly, if you take any point on the y-axis, it doesn't have any x coordinate, it doesn't have any z coordinate, it will have just only y coordinate. So any point will be of the form 0, y. And similarly, if you take any point on the z-axis, it doesn't have x coordinate, it doesn't have y coordinate, it just has the z coordinate. Okay, so please make sure that you understand. This is a very basic setup, so please make sure that you understand this. So these are the axes. So you always have two things to do. Okay, one is understanding them geometrically, and two is understanding them using numbers or algebra. Okay, so you should be able to do both. Okay, so geometrically, what's happening? What am I talking about? But what do they mean algebraically using numbers or symbols? Okay, so there will be two versions for everything. So for instance, geometrically, the axis is just x-axis, the axis line that you see, but algebraically, it's given by points of the form x, 0, 0. Similarly, y-axis is just y-axis, the axis line that you see, but if you think of the numbers, it's 0, y, 0. Z-axis is just z-axis that you've drawn, it's a vertical axis, but the coordinates are 0, 0, z. Okay, that's something to know. Okay, so these are very basic things. And now you want to know what XY plane is. So what is an XY plane? XY plane is the plane that you see, the plane containing X and Y axes. So you have these three axes. So and now if you take any of these two lines, so if you take X and Y line, you see that there's a plane moving through these XY lines, right? So I can draw the plane. So this plane, for instance, is the plane moving through X and Y. So that plane is called XY plane because it passes through X and Y axes. Okay. So geometrically, it's obvious. You take the two lines, and through the two lines, there is a plane passing through those two lines. So in our convention, it's a horizontal plane, right? It contains both X and Y axes. But what does it algebraically mean? Because it's XY plane, it doesn't have any height. So there is no, when you are on the XY plane, you don't have any Z coordinate. So that means that all the points on the XY plane look like X, Y, 0. Okay. So that means that the equation of the plane is Z equals 0. That means Z coordinate of every point on the plane is just Z equals 0. There is no Z coordinate. So yeah, so is this clear? So please try to make sense out of it. There's a geometric plane passing through both X and Y axis, but algebraically it will have coordinates like from 10, 5, and 0. So the third coordinate will always be 0 because you're on the XY plane. There is no distance along the Z axis. So that's why all the third coordinate will be 0. So you can algebraically say that the points of the plane are given by Z equals 0, or another way to say it is that all the points will be of the form x, y, 0. Okay, so that's for XY plane. Similarly, say now Z axis, you can think of YZ axis. YZ axis is this plane. So you see this other plane moving through, it's a vertical plane moving through X, so Y and Z axis. So that vertical plane is called the YZ axis, and it passes through Y and Z. So geometrically, that's obvious. It's a plane that's passing through Y and Z. And algebraically, again, it doesn't have any X coordinates. So that means all the points will be 0, Y, Z. Okay. So that is 0, Y, Z are the coordinates on that plane because X equals 0. So the equation of that plane is given by X equals 0. So if you want to determine any point on the plane, all you need to say is that X equals 0. right? Every point on the plane has one common thing, is that there is no x coordinate. So that's for YZ axis. And now there is one more, there's one more vertical plane, the third vertical plane, right, which meets there is a one horizontal plane, one another vertical plane, and this is another vertical plane. So okay, so this vertical plane passes to x-axis and z-axis, so that's why it's called xz axis. And because there's no y coordinate, the coordinates will be x comma 0 comma z. And the equation of this plane is, because there is no y coordinate, is just y equals 0. Okay, so these are some basic objects that you see in three-dimensional systems. Okay, first of them are these axes, x, y, z axes, and then there are these planes, x, y plane, y, z plane, and x, z plane. Okay, so these are these objects that you see. So again, as I said, to visualize all of these ideas, so please try to look around in your room, the corner of the room, for instance, and you can think of any corner of the room around you will meet in will have 3 lines and 3 planes. So 3 lines and 3 planes. Okay. You can think of those 3 lines as x, y, z, and then you'll see some planes passing through. So you can, this is basically what happens. Okay, so you can think of this as x-axis, this is y-axis, and this is z-axis. So any rectangular cuboidal stuff that you see, you can think of as showing you some aspects of the axes. So you can think of, if you take any cuboidal shape, like a room, for instance, and this is the corner of the room, you can think of one of the line that passes is x-axis, another is y-axis, and the one passing above is z-axis. So now, so this is the horizontal guy, is the xy plane, and the front face, the face with x and z. So this face is the xz plane, and there's a plane passing through z and y. So that is zy axis. Oh, the right hand rule is just that if you have x here, if you have x and y, so you move your fingers. Okay, I don't think you can see me doing that. Okay, so put your fingers on the axis, so, and you move your fingers from x to y. So as you move your fingers from x to y like this, your thumb finger will point towards z axis. Okay, if you move from x to y, your fingers, whatever direction that you see is the z axis, right? That's obvious. Like when you move from x to y, your thumb is pointing upwards. Is that here? I don't know if I. So if you have play. If so, okay. So imagine that. Let's see. So, okay, I'm not sure if you can see so. So there are 2 corners here. So I think of this as x-axis and this is y-axis. And what I'm doing is I put my hand like this and I try to move from x-axis to y-axis. So as I move my hand from x-axis to the y-axis, the thumb finger points towards upside, like in this case, above the paper. So that's why the above the paper is the z-axis. So from x to y, if you move, you will see that it is the z-axis. So for instance, so if x and y are drawn like this, you'll see that the z-axis is above the plane. But if someone draws x axis here, y axis here, okay. So if you move from x to y, now you will see that your finger will point downwards. So that means that the z-axis is inside the plane. Previously it was, is that clear? If x is here, y is here, the z-axis will be inside the plane. If x is here, y is here, the z-axis will be above the plane. So that is what the right hand rule says. If in general you can, if you draw x and y in this way, z will be upwards. But if you draw x and y like this, the z will be inside. That's because you can imagine that if you see it from the other side of the plane, like, the z-axis will be upside towards for the other side of this plane, but for us it will be below the plane. Okay, so that's the right hand rule. Okay, so questions on this? Is it clear? I'm not sure. It's not easy to show here. So that's why. Like just draw x and y and move your fingers from x to y, and that will point towards the z-axis. Okay, so let's see. I don't. Yeah, it's hard to show. Okay, so what I'm saying is, so imagine that you move, so align your palm along x-axis, and you try to move your palm towards y-axis. So if you first put your palm along x-axis and you try to move towards y-axis. So imagine that your palm is x-axis and you move towards y-axis, then your thumb finger will point towards z-axis. So in this case, if this is the picture, if I try to put my palm on x-axis and move towards y-axis, my thumb finger is up above the plane. So that's why the z-axis will be above the plane. But in this other case, if I put my palm on the x-axis and try to move towards y-axis, my thumb finger will point inside the plane. Yeah, so that's good. Yeah, so try to just imagine that you're moving the x-axis onto the y-axis. So you have this, so you have this axis here. So imagine that you're moving to that axis towards y, and wherever your finger points, the thumb finger points, that is the z-axis. Okay. So maybe I'll okay. So if this is still not clear, I'll try to kind of make a video which shows my hands and stuff clearly, or you can also see them online. I'll try to post something. Okay. Okay. So is the coordinate system clear? Like it's x, y, and z axis. Instead of just x and y axis, you have x, y, and the z axis perpendicular to x and y. Okay. So so let's see if you understand this stuff. Let's solve some questions. So can you guys? Oh, so these are some questions. I want you to work on them. So let's see how we do this. Maybe I can set some breakout rooms. Okay, so please try to think about these questions. The questions are, how do you determine what is the relation between equation of plane, xy plane, a plane parallel to the xy plane, and it's a height 3 above the plane. So if you think of this as the xy plane, there is a plane which is parallel to the xy plane and a height of 3 above the plane. And I want you to write down the equation of that plane. So what do you think will be the equation of that plane? Okay, so we don't have a lot of time, so let me, so yeah, so it's, so answer is z equals 3, right? So if you have a plane here and another plane parallel to that plane, the only difference between this plane and that plane is it has the z coordinate is exactly equal to 3. So that's why the equation of this plane will be z equals 3, right? The xy plane won't have any z coordinates because it's at height 0. But when you take a plane which is above the xy plane at height 3, it is z equals 3. Okay. So just z is the height, so height is 3. So that's what he's telling you. So the equation is z equals 3. Okay. Now that's fine. So what about, how do the points satisfying x equals 2 look like? Okay, so think about points satisfying x equals 2. So what kind of object is it? Yeah, so if x equals 0, that means that it is the yz plane, right? X equals 0 implies yz plane. So x equals 2 means just a plane parallel to yz plane. Okay, is that clear? So it's basically a plane. So in this picture, it's just a plane that passes through, so this plane. So you can imagine there's a line there. On that line, you draw a vertical plane, x equals 2, right? So that vertical plane passing through that, so you can imagine something. So this vertical plane is x equals 2, right? It's just you're making sure that x is always equal to 2, so that determines a plane x equals 2. So it's parallel to the yz axis. Oh, so you shouldn't call it height. It is passing through x equals 2. So because it's a vertical plane, right? It's a shifted plane. So you should call it a plane parallel to x equals 2 on the, say, you can call it on the right if you want it. How is it a plane if z equals 3? Yeah, so if z equals 3 means that, so z equals 0 is the horizontal plane. Z equals 3 is all, so all the points which are at a height 3 will have z equals 3. The xy coordinates can change, but they all have the coordinates z equals 3. Okay. Similarly, yeah, so I'm talking about 3 dimensions. So if z equals 3, that means that you know the height, but you don't know what is the other coordinate. You can move what is x coordinate, what is the y coordinate. So x and y coordinates can be anything, but the z will be along that plane. So this is one plane. So this will be, so this is one plane here. This is another plane. Just if my tablet is the xy plane, this will be the z equals 3 plane. It's just slightly shifted. We have z, it is at a height 3, but it's just still the plane. And next, what is the intersection of x equals 3 and y equals 2? So x equals 3 and y equals 4. Yeah, so you can see that if x equals 3, y equals 4, that means that it will always pass through the point. Yeah, so it's a line perpendicular to xy plane, and it passes through 3, 4, and 0. Okay, so some issue with my screen share. Okay, maybe I have to use some other app. This was working with the other big blue button. I think with Zoom it's something is happening. Okay, so yeah, so if you have the planes which are x equals 3 and y equals 4, if you draw two of those planes, you see that those two planes intersect in a line. X, and the line just basically passes through this point 3, 4, and 0. Okay, and similarly, if you draw, so what is the intersection for x equals 3, y equals 4, and z equals 6? You'll see that all of them will just intersect at a single point. You have three planes, and the three planes will intersect at this point 3, 4, and 6.
Oh, Professor, we can't see your tablet right now.
Seriously? Okay. Okay. Yeah. Give me a second. Okay. I don't know why. Yeah. Okay. Can you see it now?
Yeah, that's perfect. Thank you.
Yeah. Okay. So if you take the intersection of x equals 3, y equals 4, and z equals 6, it will be three planes, two vertical planes and one horizontal plane. All of them intersect in a corner. The corner is just 3, 4, and 6. It's like the planes at the corner of our rooms. So they intersect at one point, and the point would be, so because it's saying you can imagine geometrically what's happening, but algebraically it's very simple. So you know x equals 3, y equals 4, and z equals 6. So the point has to be just 3, 4, and 6. Okay, you don't even need to visualize it. So algebraically it's very simple. So if you know what x is, you know what y is, and you know what z is. So the intersection will be 3, 4, and 6.
For number 3,
yeah.
why is it 340? Shouldn't it be 34Z?
Yeah. I mean 3, 4, a line passing through 3, 4, and 0. So 3, 4, and 6. Yes. So it's one line. Yeah. Okay. So that's some basics about coordinate systems. So there are other problems. So how do you interpret z greater than or equal to 0? Right? So z greater than or equal to 0, if you try to think of, is just you are saying that the height is always positive. That means that it is the space which is above the horizontal plane. So this is half space. Okay. So z is always positive. That means the height is positive. So this gives you half of the space. It's the space above the horizontal plane. If you think of something as the horizontal plane, every point above the horizontal plane is z greater than or equal to 0. So what is y equals -3? Again, it's a plane parallel to xz plane passing through y equals. So okay, so y equals -3 is a plane it's a parallel plane to xz plane. Okay, similarly, I advise you to do these exercises. It's just z equals 0. That means that you are on the xy plane. X is less than or equal to 0. Y is less than or equal to 0. That means that you are on this, on the xy plane. So this is xy. X is less than or equal to 0, z is less than or equal to 0. That means you have this quadrant, right? Half the second quadrant on the horizontal plane is given by the third equation. And
Excuse,
yeah,
is it the third quadrant instead of the second one? Because
oh
y
yeah,
would still
yeah.
be
Sorry.
greater.
Y is negative. Sorry. Okay. So okay. Yeah, I'm sorry. So y is negative.
Thanks for the clarification.
Yeah. Okay. So both x and y are negative. So so it is this coordinate, third coordinate. Okay. Similarly, the fourth is just everything is positive. X is positive, y is positive, and z is positive. That means that you could think of it as the octant. It is just if you split the space into, you can think of splitting a space into 8 octants, just like we divide the space here into 4 quadrants. You can think of space divided into 8 octants, and the space and a positive, the first octant is what you get when you divide, right? X greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. So you have 8 octants. So at that point. Similarly, 0 is less than or equal to x is less than or equal to 1 will be a region in between two planes. It's between the planes x equals 0 and the planes x equals 1. So it's a slab if there are two planes and the region in between those two planes, right? If you have two planes and everything in between the planes is like a horizontal slab of, like, you can think of it as infinite thick object. Okay, horizontal object. Sorry, a vertical object. Okay, that's 0 is less than or equal to x is less than or equal to 1. Similarly, y equals -2 and z equals 1. Again, there are two planes, they intersect on a line. Okay, so y equals 2 and z equals -2 and z equals 2 will intersect on the line x minus 2 and 2. As x varies, you'll see that you get a different line. Okay, so this is a line which is parallel to the x-axis. Okay, so these are some things. So I advise you to like kind of practice thinking geometrically in 3 coordinates. So for instance, if you want to find points which satisfy x squared plus y squared equals 4 and z equals 3, how do you do that? Okay, so let's see what you get if you do that. So z equals 3, that means that you are on the plane parallel to the x horizontal plane. So z equals 3 means you are on a plane at a height 3. And x squared plus y squared equals 4. If you guys remember, it's the equation of a circle of radius 2. Okay, so this is a circle of radius 2, and z equals 3 tells you that you are at a height 3. So that means that the equation determines a circle of radius 2. So a circle of radius 2 on a plane which is not the xy plane, but it's a plane which is slightly shifted at a height z equals 3. Okay, again, there is an issue. Okay, fine. Okay, so that's how you do stuff with coordinate systems. Let's see. So I guess we are done for today. So I'll see you guys on Monday. So please read 12.1, 12.2, and 12.3. So we'll discuss stuff.
Wait, we don't have class on Monday.
Oh, sorry. Okay. Yeah. So the Monday's lecture will be on Tuesday. So we'll meet on Tuesday. Yeah. Right. So the schedule of Tuesday is for the Monday schedule. So we'll meet on Tuesday. Okay. So Tuesday at the same time. So it's a change. The schedule is changed, so it will meet on Tuesday. Okay. Yes, I'll post the notes. Yeah, I'll post the slides and I'll post something else. You'll have all of them on Canvas. Okay. So assignments in Canvas. So what? Yeah, you'll see everything on Canvas. Everything will be on Canvas. Yeah. So okay. So if anyone wants to ask any specific questions, you can stay around and ask questions. So you can turn on your microphone for your webcam, and if you want to talk, we can talk.
Professor, is there a formal label for the octants similar to quadrants?
No, I don't think people label them as one. Yeah, again, it depends on your, like even 1, 2, 3, 4 is like a convention, right?
Yeah.
So yeah, I mean, people have names if in some kind of, I mean, it depends on what you're working on. So not very specific, general kind of namings. Based, if you're working in a specific area, maybe you'll have names based on what some application that you have in mind. But in general, we don't have names.
Okay. All right. Awesome. Thank you. All right. Have a great day, Professor.
Yeah. Okay. Yeah. Thanks. Okay. So we have a Monday class that is shifted to Tuesday. Okay. So the Tuesday of next week is, yeah, all Monday classes are on Tuesday. Yes.
So then on Wednesday, do we follow the Wednesday schedule or the Tuesday schedule?
I'm not sure about the Wednesday. I think it's just Tuesday that is shifted to Monday, if I remember. So you should check your schedules on. Yeah, I'm not sure. Like, yeah. So it's I'm not really sure about Wednesday, but like there's no change on Thursday. And Tuesday is going to be Monday. So probably it's just Tuesday that's going to be different.
So we're just missing like a Tuesday, like whatever we have on Tuesday.
Yeah, because you probably you started with this week you started with the Tuesday, so that's why we missed the Monday, so that's why we probably shifted the Monday to be.
Okay.
Okay, any other questions?
Yeah, can I talk to you privately after class? I have a quick question for you.
Yeah, okay.
All right. Have a good day, Professor. I'll see you later.
Okay, yeah.